Hello everyone, I am Varun Joshi and welcome to Cloud with Varjosh, where we deal with cloud, DevOps, and everything in between. If you are preparing for CKA or Kubernetes interviews, I invite you to try the CKA playlist. If you are unsure whether this series is worth your time, pick one topic you do not fully understand. For example, stateful sets, ingress, DNS, or gateway API, and watch that single lesson to see how clearly it resolves your confusion. You can treat the playlist as a topic library or follow it end to end. I am confident you will take away something practical within minutes of following it. Now let's come to this masterclass. This troubleshooting masterclass is a single cut that stitches day 22, day 57, and day 58 from my CKA series into one flow for learners who want one single session to cover everything troubleshooting. It stands on its own. You do not need to jump across days because the combined GitHub notes are linked in the description. So if you hear me say day 7 or day 10, those are references to the CKA playlist, which I have arranged by days for learners who prefer a sequential approach like many of us do. What we will cover in this masterclass: we will start with control plane troubleshooting. Here we will discuss control plane essentials and static pods, then live diagnosis and recovery of common failures. We keep it hands on. I break the cluster and fix it with you for each scenario that you see on your screen. We will then move to data plane troubleshooting. Here we will understand data plane foundations, kubelet and networking checks, service reachability and DNS. Again, fully hands-on with real errors and real fixes. After that, we will move on to the last section of this masterclass, which is pods and applications. We will discuss about lifecycle, termination, restart, and image pulls. This section includes a bit of theory to stitch the demo together so the cause and effect is clear. If you find value in this session, say a quick hello in the comments. If you have any feedback, mention it in the comments. If you have any suggestions for improvement, then mention that as well. If you feel like the video and subscribe so that this kind of deep real world content reaches more people. With that said, let's get started. First, I will move to the GitHub repository of this lecture so that I can let you know what are the prereqs for this lecture. So I'll click here and I will go here. The first prereq is Kubernetes architecture. And this goes without saying. In this lecture, we are troubleshooting the control plane components. And if you do not understand how the control plane components stitch together and work for your workloads to run smoothly, then there is no point in troubleshooting that. So I would highly recommend you to not only just know what each component in the control plane does, but also understand what role do they play when you, let's say, create a deployment. And in day 7, that is exactly what we have done. We discussed the Kubernetes architecture along with kubeproxy, and then we stitched the entire thing together by telling you how each component plays a role when you create a deployment. Then second prereq is day 15, that is manual scheduling and static pods. Now, who scheduled the scheduler pod? Can you answer that question? What are static pods? Can you answer that? Now, this is a very important lecture in my opinion, because manual scheduling and static pods, they are directly associated with control plane troubleshooting. So if you have any gaps in your understanding, then do watch day 15's lecture. And finally, if you do not understand TLS, if you do not understand how two-way trust in MTLS works, then there is no point in troubleshooting certificate problems. So this is a must. You must understand TLS in Kubernetes. Now, I have a 3.5 hours TLS in Kubernetes masterclass in this channel. So do watch that. In case you want to watch in parts, just go to the Kubernetes CKA playlist and search for TLS, and you will get to know a 4-part series where we have discussed everything from Kubernetes context to how MTLS works to how you create a user and give access to that user to your cluster. So it is of utmost importance that you understand TLS. Now that we have gotten that off our way, let's go to the terminal and see what we have with us. So here I am logged into my control plane, and this is the cluster that we ourselves created a few days back, and then we also upgraded this cluster. So if I run kubectl get nodes here, then you see I right now have a 2-node cluster. I switched off worker 2 because for this demo we only need 2 nodes. One will act as a worker and second is our control plane. And I want you to know that I have only spun a worker node because we will be running few workloads, and those workloads will be running on worker 1. And then there is a control plane. I want you to know that this control plane node has all your control plane components. So it has your etcd, it has your API server, the controller manager, and also the scheduler. So if I go to my diagrams here and I go to day 7, then what I want to show you is this is my control plane, and then all these components that you see here apart from the cloud controller manager are deployed onto the same node. And I also want you to know that in certain environments you would also see that etcd is deployed onto a separate server. In that scenario you will have a different VM which will be running your etcd node, and you could have multiple servers that are running your etcd nodes and also multiple servers which are running your API server. And this is done for high availability, and we briefly talked about this while we were creating the cluster and also while we were upgrading the cluster. Now let's come back here. Now all the control plane components, if I run kubectl get pods and I add -n kube system here, then you would see that all the control plane pods are here and they have a specific nomenclature. So here is your kube scheduler, it has control plane suffixed. Here is your kube controller manager, which also has control plane suffixed, and similarly API server and the etcd node as well has this control plane suffix. Now this is not suffixed because these are control plane components. I want you to understand that very clearly. They are suffixed here because the VM that I have created has the name control plane. That is the only reason they have this name. Now, why this naming convention? Why other pods do not adhere to this naming convention, which the control plane components are adhering to? This is because your control plane components are running as static pods. So anything that runs as static pods would have the name that you have defined in your manifest. So the manifest for kube scheduler would have defined the name to be kube-scheduler, and then this is the node name. At the very last, the node name is suffixed when I talk about static pods. That is the reason they have a naming convention like this. The manifests for your static pods is placed in etc kubernetes manifest, and I would want you to remember this location for your exam because this is the location that you will be dealing with a lot. So if I press ls, you see all the manifests for your static pods are placed in this location, and kubelet, which runs on every node that has pods, that kubelet will be scanning this location, and whatever manifests that kubelet sees in this location, it will create a pod for that manifest. We are seeing the same behavior for control plane. So even if you delete any of the control plane components directly, like kubectl delete pods -n kube system, if you delete some pod, then that pod will be automatically created because kubelet is monitoring this location, and it will see, oh, the pod is not there, and it will create the pod. Another question that comes to mind is, if I run kubectl get pods like we did here, kubectl get pods -n kube system, we understand that whenever we are running any kubectl commands, the entry point to our cluster is the API server. So we cannot enter our cluster without the interference of the API server. It's the entry point to our cluster, and not just for us. Even if any components within the Kubernetes cluster are talking to each other, API server acts as a central bus which facilitates the communication. So API server is a highly important component in your control plane. So if I talk about here, you might be wondering, Varun, if these manifests are directly created by kubelet, then how does API server know about it? Because the manifests, the workloads that we are running on our Kubernetes cluster, we execute them via kubectl commands, and they go through the API server, and that is how the API server knows about them. But how does the API server know about these static pods? Because it is showing static pods whenever I run this command. It knows about them because there is a mirror object created for all the static pods in the API server, which is why when you run these commands, you see the static pods as well. Now you could run static pods in all your nodes. So you can run your static pods in your worker nodes as well, because all of them will have this location. You just go to this location and add the manifest that you want to run as a static pod, and once you do that, you will see the same structure. You will see the name of that pod, and then hyphen at the very last, you will see the node name. So if it is worker1, you would see my pod. If the name of the pod was my pod hyphen worker1. So we have the understanding of static pods. Another thing I want to talk about before we start with our scenarios is, we are not supplying any credentials when we are running these commands. But how does the authentication work? Because we know for a fact that there is MTLS in Kubernetes. What does MTLS mean? MTLS is mutual TLS. Both the parties provide their certificate to prove they are indeed what they are saying they are. So for example, if I connect to the API server, it is the API server which will first present its certificate. I, as Varun Joshi, with my kubectl client, will verify that it is indeed the API server I want to connect to. And then it is Varun, the client, who will present its certificate, and then API server will verify that it is indeed Varun, and only then the communication will move forward. So in MTLS, both client and server must prove their identities, and it is the server who proves its identity first. We have this understanding now, and not just Varun. So even if I talk about the intra-cluster communication between control plane components, so for example, if scheduler wants to see whether it has any workloads that scheduler must schedule, then scheduler also has a kubeconfig file which it uses to interact with the API server, and API server here first presents its certificate to scheduler. Scheduler verifies that it is indeed the API server I want to connect to, and then scheduler presents its certificate to the API server because scheduler is the client, and then API server verifies that it is indeed the scheduler I want to speak to, and finally the communication happens. So understanding MTLS is of paramount importance, and in our TLS masterclass we broke this down to the location where these certs are and how they are working, which is the certificate authority that is signing these certificates, and so on. So I would recommend you watch that lecture. But Varun, why are you bringing this up? Now I want you to know that there is a kube configuration file which is also called kubeconfig file. Kubeconfig file is the one that holds the information about your authentication, because how does this kubectl client know what is the address of my API server, what is the certificate, what that I should present as a client? So all these things are stored in the kubeconfig file. But Varun, if I am managing multiple clusters, then how do I do that? So you can save information about multiple clusters in your kubeconfig file, and then you can use Kubernetes context, which you can view. If I run kubectl config view, then you can see my kubeconfig file only has information about one cluster, which is the one that I am currently dealing with. But you, if as a DevOps engineer are dealing with multiple clusters, then you see clusters here is a list. So it is one cluster. If you are dealing with 10 clusters, you will have information about those 10 clusters here. Then you have users section where you have multiple users. And then you have context. Context is something that marries the cluster to the user. So if I switch to, let's say, context 1, then I will be running commands in cluster 1 with a specific user. If I switch to, let's say, context 2, then I will be running commands in cluster 2 where the user is user 2. So these things we have discussed deeply in the Kubernetes context section, which was also part of the TLS series. Okay, now we have understood these basics. So let's get started with our troubleshooting. I will clear my screen. I will CD to my home location, and then let's start with scenario 1, which is API server connection refused. So let's run kubectl get pods. The connection to the server this was refused. Did you specify the right host or port? So firstly, hostname -i will tell me that the IP of the server that I am connected to is this one, and I see the same server here. So I am logged into the control node itself. I am SSH'd into the control node itself. So the API server is listening on port 6443 as this line suggests. Now firstly, what I want to verify is my server actually listening on port 6443 or not? So for this I will run ss. ss implies for socket statistics. This will tell you about your live connections, established connections, and so on. And then I will write TLPNS. So here T stands for TCP connections, L stands for listening, P stands for processes, N stands for do not do the DNS lookup for me, and then S stands for summary. I'll also add sudo so that I also see the process names. I'll press enter, and this will give me a general idea of what all ports my server is listening on. I want you to clearly know that when you are deploying, let's say, an application onto your Linux box, your application will be using a certain port, will be listening on a specific port, and when you run this command you should see that port here, because if you don't see that port here, then your server is not listening for that connection. So right now, whatever ports that you see here, my server is listening on that port, and here you can see what all processes are there. So if you look into it, there is only SSH which is associated with my logging into the system. Rest all the ports are used by something Kubernetes. So if you see, this is etcd, this is kube controller, scheduler, proxy, kubelet, and so on. So understand, if you want to check how secure my system is, then you can run this command and see on which all ports my server is listening. Here is the local port, which implies this server, and you see this is the IP of our server. And in peer address you will see a wildcard here. Now this wildcard here does not mean that anyone can SSH into your box. It only means that they can if you have allowed that. So for example, if you know that we created security groups for our control plane, and the security groups that we created for our control and data plane were restrictive. Hence, if I click on my control plane security group and I go to inbound, I have only allowed the communication that is needed. Rest, everything is blocked. So my security group, and then there is also a firewall at OS level. So if you have configured all these layers, and then you also have a network firewall that is fronting your application, then you must allow that port in every layer. Only then the communication will work. So this output is just saying anyone can connect to it, but anyone must have access to this server. Only then they can make that connection happen. So this output clearly shows me that this server is not listening on port 6443, and that is, I think, the reason the connection was refused. And we can also, just to verify, quickly write grep-i 6443, and this will show me that my server is not listening on port 6443. So we understand that. What do we do next? Next, what we can do is, we have something called CRI-CTL. We have discussed this during our cluster creation and the cluster upgrade process. But what CRI-CTL is, when Docker was a prominent runtime, we used to run Docker PS in our hosts to see what all containers are running, because you know, at the very high level, pods are just containers. Pods are just a wrapper for containers. So if I run Docker as the container runtime, I could use Docker utility to interact with my containers. In our scenario, what we have is containerd. Containerd is also an extremely popular runtime, which is the default for most of the Kubernetes implementations, because containerd, like Kubernetes, is a CNCF project. So if I run CRI-CTL PS, I'll also have to add a sudo here. Then I can see the containers that are running on my host. Right now, understand that kubectl get pods is not working for me. So how do I interact with my containers? I can interact with my containers using CRI-CTL, because I am logged into the machine that is running my control plane component, and that point is very important. kubectl uses the kubectl client's authentication information to connect with your API server. Your API server is listening on port 6443, which is not reachable. Hence, kubectl utility cannot interact with your Kubernetes cluster. But CRI-CTL will show me all the containers that are running on my control plane node. Understand that we used kubectl to interact with the entire Kubernetes cluster, including the worker nodes. But here CRI-CTL is only showing me the containers that are running in this node. So if I run this command on worker node 1, for example, then it will only show me the pods that are running in worker 1. So what I understand from this output is, scheduler is running, controller manager is running, etcd is running, but there is no information about the API server. If there is no information about the API server, I must check the logs. And in our previous lecture, where we discussed Kubernetes observability, we understood monitoring and logging, and we deeply discussed how the native logging works in Kubernetes. So we know where our logs are. So what I will now do is I will hit sudo -i so that I become the root user. This will just make me opening files pretty easy. I will not have to add sudo, and I can show you the entire thing with simple commands. So what I will do is I will do cat. I want to cat on var log. Here you have pods, and inside pods the directory that I want to go into is kube system kube API server. This is the one I am interested in because this holds the logs for my API server. So I will write kube system here, and then here it is kube API server, and then the directory path is here. Then I'll press tab, it is kube API server. Then there is only one log file there named 6.log. I will open this log file, and here is the error. It says standard error, invalid argument 172.31.35.1556. What kind of IP address is this? For advertise address. And I want you to understand that while configuring our cluster, while creating our cluster, we supplied this advertise address flag in our kubeadm command, which told my control plane node, which told my virtual machine that this is the API server's address, and that address is not matching with what we have right now. What we have right now is something gibberish, because the fourth octet of the IP address cannot have this value. And so we have figured out that this is the problem, that the advertise address is wrongly configured. And why we were able to do that? Because we know CRI/CTL, we know where the logs are stored, because everything when you are troubleshooting something is connected. So understanding the foundations is of paramount importance. So now let's do one thing. Now let's fix this. And how do I fix this? We just learned where is the manifest for kube API server. It is in the static pod directory. And where is the static pod manifests directory? It's in etc kubernetes manifest. So I'll exit from this root user. I will write sudo, I will write vim etc kubernetes manifests, and then I want to edit the kube API server's manifest. I'll open this, and here is the problem, dear friends. Advertise address is wrongly put here. Now this is not the only thing that you would see. At times you will also see that the certificate path is wrongly configured, and you can only fix that if you know what you are doing. If you understand TLS, you know where the certificates reside, you know where the public and private keys are stored. So I will hit I here, and I will remove the extra 5 from here, because I know the IP address of my API server is this one. The fourth octet is 156. I'll do this. I'll hit escape, shift ZZ to save this file. Understand that as soon as I edit this file, kubelet is constantly monitoring this directory. It will see that a file has been changed. It will recreate the API server for us. So let's allow it 1, 2, 3, 4, 5. Let's run kubectl get pods now. Tada! It works now. It works because we fixed a problem. And these are the kind of problems that you will see in your exam. So I will clear my screen now. I will pause the recording, and I will check for scenario 2. Now, before I move to scenario 2, I want to spend some time in this command. So sudo ss -tlpns. We know that this will show us the listening ports to me. But what if I want to see what all connections have been established? And also I would recommend you read about these ports, because I know that my cluster does not have HAHCD. In that scenario, port 2380 is never used. Always 2379 is used. API server interacts with HCD, and we know it is only the API server that interacts with HCD, and it does that on port 2379. 2380 is only used when you have multiple HCDs. HCDs use these ports for leader selection and all those things. They use port 2380, but in our scenario we won't be using it. Then read about these ports. Now this is used by something related to kubelet, then kubeproxy, and all of them. So do read about them. Now what I want to show you is, I want to show you the established connection, that how do I know that who has made connections to my API server or to my virtual machine in this example, because in the end this is a virtual machine that is hosting my Kubernetes components. So I will now run sudo ss-tnp. let's get rid of the listening and let's get rid of the summary. Because why I am not showing the listening now? Because I want to show you the connections that are established. I'll write state established. This will show me all the established connections, and there are so many. Now if I want to, let's say, check something, I want to check whether there is something that is connected via SSH. So I can just write grep-i 22. This will show me that these all are the connections that are using 22 in some way, but exactly port 22 will only be using by SSH. And here you see there is a connection made to 22. And why do I know there is a connection made? Because in my command I wrote state established, as in connection was established, and you see this is my IP address and this is the random port, source port, that my laptop would have generated to make connection to this server. Now that we have this understanding, let's clear our screens, and now let's move to our second scenario. So now we are in scenario 2, that is HCD troubleshooting. So let's run kubectl get pods, and the command is stuck. Now why it is stuck, we will see the logs and all those things, but firstly I want you to know that whenever I run kubectl get pods, API server is in turn interacting with HCD and fetching that information. If your HCD is not running, then kubectl commands, when you are trying to create something or trying to fetch something, so read, write, modify, all these things will not work properly because your communication between the API server and HCD is broken. So let's wait for this to error out, and let's read out what the error is. The error is error from server. The server was unable to return a response in time allocated, but may still be processing the request. So without further ado, what I will do is I will run kubectl get pods again to see whether the error will come again. Now the error is different. The connection to the server, this was refused. Did you specify the right host or port? I wanted to know that error is something that we saw in our previous scenario as well. So again I will run this command and let's see what the error now is. Now it is taking some time. Let's see what error pops up. Now get HTTP this default dial this connection refused. Error from a previous attempt, read this 33962. This is the source port number. To this, read connection reset by peer. This is not giving us exactly that HCD has a problem. We know HCD has a problem because I have named this scenario HCD troubleshooting. But looking at this, it could be anything right now. So let's run CRICTL, our favorite command. CRICTL and PS. I'll have to add a sudo here. And let's see what it shows. So I am seeing the kube controller manager and I am seeing the scheduler. I do not see API server or HCD here. So the best way is let's add a -a here to see the exited containers as well. So let's see if I am seeing HCD here. So HCD is in exited state. And then if I talk about, let me search for API because this will be a task. I'll grep for API, and here is my API server, which has also exited. So I have two options here. I'll have to check the logs for both API server and HCD to fix this problem. I'll quickly do sudo I, and then what I will do is I will cat into var log pods. The name of this is kube system, and this one is, let's see the logs of HCD first. I will write HC control plane and then HCD, and there is only one log file called 4.log. My face might be obstructing it, but there is only one log file that is called 4.log. I'll press enter, and this is showing me a lot of logs. Now let's read this. Error, this caller embed register gateway failed. Error open HCD Kubernetes PKI HCD CKA.cert. If you know, the default nomenclature has CA in it. This one has CKA.crt. Now, if you do not know what happens, you will never know what happens, right? So it is CA.cert that the name is. Now, name can always be changed. They can give it a new name, but you as DevOps administrators must be able to figure out what the correct name is. So if I copy this location, and this is the location where the certificate authority data for the certificate authority that is responsible for HCD is stored. So I will go to this directory, I will cd into this directory, and then if I run ls here, I see the certificate authority's public key is this, the certificate is this, and the private key is this, but it is saying that you have configured CKA in it, which is not correct. So let's do one thing. Let's fix it. I will exit this. I will write sudo vim etc Kubernetes. We know where is the static manifest files for our control plane components. I will write etcd.yaml. I'll press enter. I will hit I, and you see here there are many certificate related fields, but we know, because we have done our TLS lectures, that the trusted certificate authority file is supplied here, because they cannot change these flags. These flags will not change, but the values they can always change. They may play with these as well, but that is extremely rare. At least I have not heard of that. They will change the values for that, and you will have to fix those things. For example, they might change this IP address, they might remove something from here. You will not know unless you know how to read this file. For example, they can change this IP here like we did in our previous lecture. They can add an extra D here in the HCD command. So keep your mind open, check the logs. Logs will tell you what is wrong, and here the logs told us that there is something wrong with the CKA.cert. So we'll remove this. I'll press escape shift ZZ to save this. Now let's wait for 1 2 3 4 5 kubectl get pods. It is still working. Let's allow this some time, because our API server pod also exited, so we might have to, let's say, remove that and have it recreated. And in that scenario, we'll have to use CRI-CTL to do that, because understand that kubectl is still not working, and I want to see the status of my API server pod. So I'll write sudo CRI-CTL ps, and let's see if our API server is running. So HCD has come in running state, but our API server is still down. So let's do one thing. I will have to recreate that pod, but why is this not automatically recreating it? Let me do one thing. I will write the same command here, but I'll also add -a, and then I will grep for API. This will show me that the API server has exited. Now let me CRI-CTL sudo CRI-CTL I'll add rm flag for remove, -f for force, and then this is the container ID, which is at the very first. I'll paste this here, I'll press enter, and this has said that the container is deleted because I see the container ID spitted out here. Then let me run that grep again, and this shows the API server is now running. So let's now run kubectl get pods to see how this behaves. Voila, we have fixed the problem. We fixed the problem because we knew what to do. Now let me clear my screen. Now let's move to scenario 3, which is also HCD troubleshooting. Let's run kubectl get pods. Again, the command has stuck. Error from server. This is a generic error. Let's run this again. Now this is saying pods is forbidden. User Kubernetes admin cannot list resource pods in API group this and namespace default, which is not true. So let's run sudo crictl get ps crictl ps, and this is showing me that HCD is running, API server is running, controller manager is running, and scheduler is also running. So all our control plane components are running and they are running fine. Then what the problem is? So for this, we'll have to see what the logs are saying. So firstly, because our API server is not reachable from us because we are running kubectl commands and API server is not accepting those. So firstly, I will have to see the logs of the API server itself. So I will write cat var log pods, and here I will write kube system kube API server, kube API server. Then the log file that I want to see is one.log, which one is the latest. So I'll press enter, and unable to authenticate, invalid bearer token service accounts Calico Taifa. This is related to Taifa, and then this one is Taifa is a component of Calico, okay, the CNI that we are using. Unable to authenticate. These are the logs I'm not interested in right now because this doesn't solve the control plane problem for me, at least for now. And we know CNI is not a problem because the control plane works just fine even when you don't have a CNI, and we saw that while we were configuring the cluster. So let's do one thing. Let's see the logs for HCD. So instead of kube API server, I will punch in HCD here and see what is the logs of HCD saying. Now we can only directly point out because I know that we are troubleshooting HCD, but in exam you will have to look further. You have to look at the logs of API server, then maybe controller manager, then scheduler, and all these things. In which direction you will look first depends on the output or the error of kubectl command. So here I will now run kube system again, and here is my HCD node, and then I will write HCD 0.log. Caller cluster version is updated. Cluster version is this, and then if I scroll up, leader at this, member ID is this, member ID is this, and then HCD data member wall, data member snap, peer URLs, client certificate. This is fine. This also looks good. If I scroll up, raft caller, this is this all these are errors, standard errors. Started to purge file, HCD data purge, and then error. So the error pertains to, because this is giving errors here, file purge message started to purge file directory var lib HCD -data member snap. This is the error. So I want to go to my static pod manifest file, the manifest file for HCD, and check what this path is. So let's do one thing. I will exit from here, and what was that path again? It was HCD var lib etc. So I will sudo vim etc kubernetes manifests, and then I want to check the HCD manifest. I'll go here, and if I see here is my data directory which says varlib etcd hyphen data. Now this is off, and I'll tell you why this is off. I'll scroll down. Here are the volumes that I am mounting. The mount path is this, the name is this. I want you to understand this very clearly. This is the mount path, okay? But if I go back up, here I'm saying data directory is varlib etcd hyphen data. Shouldn't this also be etcd? Because we are mounting something at a specific location, and here is the data directory. Data is the directory where all your database will reside, which is wrongly configured. I want you to correlate this, and this is confusing because what they have done is they have given the name here etcd hyphen data. Okay, the name is this, but the mount path is different. Understand that mount path is the path where this volume will be mounted, and it will be mounted here in etcd, but the path that they supplied here was wrong. So I have fixed that path now. I'll hit escape shift zz. I will now run sudo crictl ps hyphen a, and few of these pods have exited. So I have just made edits in etcd static pod manifest, so that would have taken a restart. So let's use grep now. Enough of this. Grep etcd, and the etcd is in running state. How about API server? They were previously also in running state. I think I'll have to take a restart of this. Okay, one API server exited and one is in running state. So let me run kubectl get pods. If this doesn't work, then but this works. If this would have not worked, I would have killed both my API server and etcd and then saw what happened. So this is another problem that you can see in the exam, and you know how to troubleshoot it. Now let's move to scenario 4. Let's run kubectl get pods. Kubectl get pods is running. Let's run kubectl get deploy. Kubectl get deploy should also work. I see I have a deployment named web. Let's scale this deployment. Kubectl scale deploy, and the name is web. I want to scale it to, let's say it has 3 replicas right now. I want to scale it to 4 replicas. I'll press enter. It says scaled. If I run kubectl get pods, I should see 4 pods, and I don't see 4 pods. I only see 3 pods of my web deployment. Now let's run kubectl get deploy that we used initially, and it says out of 4 only 3 are ready. So the 4th pod was not created, and I want you to clearly understand that we know who is responsible for ensuring that the desired state matches the current state. And what is the desired state? The desired state is 4 pods, and we only have 3 pods right now. So it is the controller manager component that is responsible for this. And under the controller manager, you have deployment controllers, replica set controllers. And here in our scenario, it is deployment and replica set controller, which should come into action and ensure there are 4 pods. But if I run kubectl get pods -n kube system, I see the controller manager pod is in crash loop back off. If controller manager pod is not running, then essentially all my controllers in Kubernetes are down. So I must ensure that this component is running. So welcome to controller manager troubleshooting. Now let's do one thing. Again, the same thing. The process remains the same. We will be checking the logs for controller manager component. And why checking the logs first is important? Because it will directly pinpoint you to the problem. So here I will quickly run sudo I, then I will run cat var log pods kube system, and here will be our kube controller manager. And here I will go to kube controller manager, then 4.log is the latest. I'll press enter. There are no logs. What is the problem here? Let's check the logs for kubelet. Maybe kubelet will have something. And we know kubelet runs as a service. So we can use journal CTL for this, and we learned this in our previous lecture, Kubernetes monitoring and logging. And here I can write the unit file's name. It is kubelet, and then I can also write -f, I believe, so it will show me the live logs. It is showing that kube controller manager is in crash loop back off. Kube controller manager, this system is reserved. Okay, this is specific to the sandbox environment. So let's hit Control C. These are not helping. Now let's run something that can help us out. So let's run kubectl describe pods -n kube system, and then here I want to check the logs for kube controller manager. I'm running a describe there, and it is saying OCI runtime create failed, runc create failed, unable to start container process, error during container init. Container initialization is the problem. So it is not even able to start the container because exec kube controller manager executable file not found in path unknown. I want you to check the spelling of this. Kube controller manager. Does the manager have double R? Maybe what we are trying to do is we are trying to start the kube controller manager using this command, and the image that the controller manager is using underneath does not understand this. So let's go to the static pod manifest like we have done before. Sudo vim etc kubernetes manifests, and here I want the kube controller manifest. I'll open this. Tada! Command that we are running is kube-controller-manager, which is wrong. I'll go to insert mode. I'll remove this R. I'll hit shift ZZ. I will now run kubectl get pods -n kube system, and the controller manager is in running state. So I will now run kubectl get deploy. It is still 3. Let's give it some time. Let's run kubectl get pods to see maybe the pod is in some kind of container creating or pending state. We don't know it yet. Oh, the pod is not yet created. Let's allow it some more time. The controllers are initiating right now. Kubectl get pods. Oh, Varun, what are you doing? I see the 4th pod now. It was created 15 seconds back. And if I run kubectl get deploy, I will see it here. Now I want to move on to scheduler troubleshooting. Okay, so we have fixed this. Let's clear our screen. Now let's do one thing. Now let's create a pod. Kubectl run my pod. I want to use image nginx, and then what I want is I'll press enter. It says the pod is created. If I run kubectl get pods, the pod is in pending state. So my pod is right now in pending state. And I want you to clearly know that when you create a pod and the pod is in pending state, the state does not change. So no crash loop back off, no error, no image error pull or something similar, just in pending state. Then it implies either the scheduler is down or scheduler cannot find a node that satisfies the requirements that you have mentioned in the pod. Now those requirements could be your node affinity, pod anti-affinity, pod affinity, your taints and tolerations, and so on. So pending state implies scheduler is down or there are constraints, and those constraints can also be resource constraints. So let's now do one thing. I will now run kubectl get pods -n kube system. And this will show me that my scheduler control plane is in crash loop back off state. We clearly know there is a problem with this pod. Let's now fix it. Now to fix it, we first must know what the problem is, and who will tell us what the problem is? The logs will tell us what the problem is. So I will write cat var logs pods, and here I want to check the logs for our scheduler. It is scheduler, scheduler, and then inside it is kube scheduler. Then we have 4.log. I'll press enter, and clearly it says generated self-signed certificate in memory, which is fine. Command failed to get delegated authentication kubeconfig. I told you that your scheduler can only schedule the pods when it has a valid kubeconfig file and MTLS is performed perfectly. Only then the communication goes further. And it says delegated authentication kubeconfig failed to get delegated authentication kubeconfig stat etc kubernetes scheduler.conf, and you see here right away scheduler.conf. It should be scheduler, right? And even if you don't know this, because when you are reading something like this, you miss that there are double R's. It happens with the best. So what you know is there is some problem with kubeconfig, and you know where kubeconfig is configured. Now I want you to know that the directory where the kubeconfigs are stored is this one, and if I press ls here, you see these are the kubeconfig files: controller manager config file, kubelets, schedulers, and super admins. This is the one that we typically use, and I'll show you how we use it in the next scenario. So for now, we know that this file has a problem. Not this file exactly, maybe the path to this file has a problem. We know that this file is placed here, but this path, that which is this one, should be mentioned correctly in our static pod manifest. So let's do one thing. I'll exit from here. I'll write sudo vim and then etc kubernetes manifests, and here I want to check the schedulers manifest. I'll press enter, and you see if I check the authentication kubeconfig file, it is here. Here it is fine, but here I have misspelled it. So I'll go into insert mode. I'll correct this quickly. Shift ZZ. I want you to know that it is not always this place that will have error. The error could be anywhere in here, and you will have to check the logs to figure out what that error is. I'll press escape, shift ZZ. This should fix my problem. First, I will run kubectl get pods -n kube system. I'll have to spell it right, of course. And then my scheduler pod is now in running state. Where is it? Oh, the scheduler pod is not visible right now. So let's hit up arrow again and let's see. Okay, now the scheduler pod is here. 4 seconds back it was created for us. Now if I run kubectl get pods now, the pod that was in pending state, my pod is now in running state. So now we understood how to fix scheduler problems. Now all of these, the logs will tell you where to look. Now I'll clear my screen. To explain the last scenario, that is scenario 6, I'll take you to the GitHub repository. I will go here and I want to quickly go to scenario. It is mentioned scenario 5 here, but this is scenario 6. So I'll press here and then I will zoom in here, and then I want to demo the certificate problem for you. Now I want you to know that all these commands are there in the documentation. So you don't have to remember the commands per se, but you have to remember in which sequence you have to run the commands, how you have to run it. And if you understand the foundations, all these things are a cakewalk for you. So firstly, I want to check when are my certificates expiring. So I'll copy this command. I will go to my terminal, I'll paste it here, and it will tell me that my certificates are valid and they are expiring on August 25, 2026. So we are good. Now, how do I simulate this? Now to simulate this, what I will do is I will change the date of my system. We'll go to 2027 so that the certificates that I have become invalid for me. Here I am doing exactly that. So I'll copy this. Now in this command, what I'm doing is I'm stopping cronid, and cronid is the service that takes care of time. I'm stopping that service, which will prohibit my system to sync time with the NTP servers. I'm just stopping that, and then I'm setting a new date and time, and this is what I'm setting. I'm setting it to 2027. 2027. So if I now run the date command, you see we are in 2027 and today's date is August 26th 2025. So I'll go back again here, and then what I want to now run is I now want to check the expiration again. Here, understand, residual time was 364 days, but if I now run this command again, you see residual time is invalid because my certificates are only valid till 2026, but the time in my system is after that. So let's go back here and rotate the certificates using kubeadm. Now kubeadm knows that the correct time is this one, 2027. Now we will renew the certificates based on this date. So I'll go here, I will copy this command to renew the certificate, then sudo kubeadm init phase kubeconfig all. What this command will do is it will fix your kubeconfig file to have the latest information. So I will copy this here. Again, I'm saying if you would have watched the TLS lecture, all of these things would be making sense to you. I'll press enter and this is saying that it has done the job. Renewed. You see this here, and I will let you read these informational messages. Extra thing is, done renewing certificates, you must restart the kube API server, kube controller manager, this. So in this step, what we are doing is, firstly, let's fix our kube config files. I'll run this command, and then it has fixed all our kube configuration files. Now you are seeing some TLS errors here. The TLS errors are here because there is a mismatch in time. Our machine has this time and it is unable to match that time with the information that is available here. Hence you are seeing TLS errors, and which is fine for our scenario right now. Oh, I didn't even show you the error that you would see. Hold on, kubectl get pods. I wanted to show you the certificate error. So what happened is, whenever you changed the system time, okay, I should have ran kubectl get pods. Upon running that, it would have shown me that you have a certificate error. So I will let you do that. Please pardon me, I forgot to run that command. After changing the time, you run that command and it will tell you that there is a certificate error, and with that you will know that there you must renew your certificate. So if I'm running it again, it is not showing me anything because I should have done that before. Anyway, let's sudo systemctl restart, because now we have renewed the certificates and it is giving us unauthorized error right now, the error that you see here, because our kubeconfig file is not yet updated. Kubeconfig file, we know that the kubeconfig file that our kubectl client is using to connect to the API server is different. What we updated in this command are the kubeconfig files that our control plane components use. Although this admin.conf file will be used by our kubectl client, but we will have to store it in the location where kubectl looks for the kubeconfig file, and we know that location is, if I cd into my home directory and I go into the .kube directory, here you see there is cd.config. If I config into this, if I cat this config file, this is the file that has my authentication information. So I will come out from here, I'll clear my screen, I will again cd into my home directory, I'll clear my screen, and then let's go here, and then I will now make the changes. What I'm saying is, in case this directory does not exist, make this directory and copy the kubeconfig file, that is admin.conf, to a file named config, and this is what will do the trick. Once this is copied, I can run the kubectl commands just fine. I will copy this all, I will paste it here. Hold on, I don't think I have restarted. I'll run the history command. I don't think I've restarted my kubelet. I have restarted the kubelet. So let's now run these commands. Control C, I will paste it here, I'll press enter, and my kubeconfig file is now updated. So if I clear my screen and I run kubectl get pods, the command is now running. Now I should have showed this to you, that what happens when this command doesn't run, but we can still do that. I'll show you how. So the age is unbelievable, right? Pod is running for more than 2 years now. So let's, and why 2 years? Because the time in our system is 2027 and we created these pods when we were in 2025. That's why the age is so much. So let's go back here. Now here is the optional cleanup. Now we'll fix the time and then we will move to the next step. So let's fix the time using this command. Actually, I only have to do this one because systemd time sync t is not being used by my distribution, I believe. I'll press enter, sudo apt install. Yeah, it doesn't understand that. I'll just run this. I think there's some problem with the comments. The comments are also part of the command. I'll have to fix this. There is space less here. And then now that we have fixed the date, let's press date. Now we are in August 26, 2025, which is the correct date. So now let's do one thing. kubectl get pods. Aha, you see that error now. Unable to connect to a server, TLS failed to verify certificate. This is the error that you will see in the exam and you will have to fix this. And how you will fix this? We have already seen that. You will renew your certificates. Now we have to fix this as well. So we will repeat the same steps again. So I'll copy all these commands and we have seen what these commands are doing. I'll press this, I'll press enter, and this will fix all of this for us. It will renew the certs. And then finally, I will copy the kubeconfig file. I'll do this. And now let's run kubectl get pods. Okay, this is also fine. Now let's check the expiration. It should also show 2026 now, which is what we expect. And now you see, previously we were seeing 25 here, August 25. Now we are saying August 26 because it is today that we renewed the certificates. So keep these things in mind. These are nuances which matter in the exam. So now our kubectl commands are running fine. Kubectl get nodes, and understand the importance of running these commands. It is imperative that you are copying the admin conf to your kubeconfig file because this one has the latest information. Now, since we are in the troubleshooting section, I hope you understand that you can only troubleshoot something when you understand the underlying foundational concepts. So like there were a few prerequisites when we were doing control plane troubleshooting. Similarly, when we are doing data plane troubleshooting, there are prerequisites, and the prerequisites for data plane troubleshooting are much more than control plane because it is the data plane where your workloads run. Hence, all the concepts that we have learned thus far, be it pod priority, preemption, admission control, pod security, security contexts, Linux capabilities, requests and limits, auto scaling, HPA, VPA, storage concepts, all of these will come together when we talk about data plane troubleshooting. So your foundations must be strong before we dive into any sort of troubleshooting. But to give you a gist of whatever examples, whatever scenarios I will deal with during this lecture, especially for those, you must understand what you see on your screen. First is day 7, where we discussed Kubernetes architecture. You must understand it thoroughly. And then there is pod termination, restart policies, image pull policy, lifecycle, and common errors. We covered this in day 22. Day 22 can also be thought of as a troubleshooting session. So go through day 22. I will not be repeating these errors in this troubleshooting scenario, so it is better if you go and watch this day. Then it is day 48. DNS is something that is of paramount importance in this channel. I think we have a very clear video on Kubernetes DNS which will help you understand how DNS is handled in Kubernetes. In general, there is also a DNS lecture on this channel which deals with what is DNS, how DNS works. So if you do not understand DNS concepts to begin with, then start first with what DNS is and how it works. I will link that in the description. And then when you understand how DNS works, then you can understand how Kubernetes deals with DNS, especially with a component called CoreDNS. And like in the control plane lecture, TLS understanding is must, how TLS works in Kubernetes, because data plane component like kubelet also uses TLS for secure communication. With that being said, let's see what I want to discuss. So let's start with a quick tour of data plane. So what I will do is I'll take you back to day 7 where we discussed the Kubernetes architecture. I will zoom in a little. So what we discussed in the previous lecture were these components. Essentially, anything that you see in blue here, we discussed them in the control plane troubleshooting session. Today's session will concentrate on anything that runs on the data plane. And what is there in the data plane? Your worker nodes. Each of your worker node will be running a kubeproxy, a kubelet, and also a container runtime. So kubeproxy is deployed onto the cluster as a daemon set, which ensures all the worker nodes that you add onto your Kubernetes cluster will have kubeproxy pod running because it is deployed as a daemon set, including the control plane node, as long as the daemon set that is being created has a toleration that tolerates the taint that is applied onto the control plane node. So kubeproxy can be thought of as a traffic director. So what happens when a request comes to the virtual IP of your service? It is your service that decides which pod should be serving the request, and only healthy pods are given the request for catering. And why is that? Underneath, it is kubeproxy which is acting as a traffic director and distributing the traffic to your healthy pods. Then there is kubelet. What is kubelet doing? Kubelet is ensuring that the statistics of your node and also the pods that are running onto that node are sent to the API server. And why are these statistics important? These statistics are important for metrics server to work properly, so that you as administrator can run kubectl top pods, kubectl top nodes, and see what's the utilization of the workloads in your cluster. And not just this, but it also helps HPA to scale your pods depending on the load on your application. That's just one functionality. Whenever you are running commands like kubectl logs, kubectl exec, it is the API server that communicates with kubelet to give you that information. Kubelet is also responsible to see the pod specifications. Whenever you start creating a new pod, it is kubelet that sees, oh, these are the pod specifications for which a pod must be created, and it is the kubelet that informs the container runtime that start doing your job, that is start creating this container, because I have just fetched the pod specifications from the API server. And container runtime, upon instructions from kubelet, will pull the container image, will start the container, will assign IP to the container. It is not the container runtime who directly assigns the IP to your containers, to your pods. It is underneath. Container runtime communicates with the container network interface, that is the CNI, to start distributing the IP addresses to those pods. It is the container network interface, that is your CNI plugin, that ensures the IPAM in your cluster only unique addresses are assigned to the pods. Now there is a confusion between CNI and kubeproxy in a lot of folks. So I want to quickly give an analogy which will help you understand. Now a GPS system will be of no use if there are no roads. If I contrast this analogy with your Kubernetes cluster, then it is the CNI that is ensuring that the underlying infrastructure, the underlying networking is in place so that kubeproxy can appropriately direct the traffic to the responsible pod. So in essence, think of kubeproxy as the cluster's traffic director. When a request hits a service, it picks a backend pod and only forwards to healthy backend. So if CNI lays the roads, kubeproxy is the GPS that routes you over them to the right destination. So CNI is the one responsible for pod to pod communication. It is the one who is assigning IP addresses, managing IPAM in your cluster, and then kubeproxy is distributing the traffic to the appropriate pods. That's all there is to kubeproxy and CNI. Now, if you want a detailed description of all these components, then again, day 7 is your thing to do. Now that we have this understanding, let's go to our terminal and see what our cluster looks like. So if I run kubectl get nodes, you see that I have a 2-node cluster. There is one control plane and there is one worker node. This cluster is running the latest version of Kubernetes, which is 1.33.4. The version that you see here is the version of the kubelet, not the version of the API server, or what is often referred to as the version of Kubernetes. So if I want to check the version of my API server or my Kubernetes cluster, and I want to check the version of my kubectl client, what I do is I run kubectl version command. This will give me the client version 1.33.4. that is, my kubectl client is this version, and my server, my Kubernetes cluster, is of version 1.33.4, and so is my kubelet. So we created this cluster in this series itself, and we also upgraded this cluster to 1.33.4 in this series itself. So if you want to understand how do you build a kubeadm cluster and then also how you upgrade the kubeadm cluster, then do watch lectures that are already available in this CKA playlist. With that understanding, let's get started with scenario 1. So scenario 1 is kubelet troubleshooting. So what I will do is I will run kubectl get nodes. The nodes are still in healthy status. Let's give it some time so that worker 1 goes to not ready status. Now the status of my worker 1 is not ready, which is not nice. I'll show you something. I will run kubectl get pods. There are few pods that are already running in my cluster. So if I write -o wide here, these pods are running in worker 1. I want you to clearly know that even though the status of worker 1 right now is not ready, the pods are still running. And I also want you to know that after 5 minutes of nodes status being not ready, these pods will be terminated. Now, why would they be terminated, Varun? So let's do one thing. kubectl describe nodes. I want to describe worker 1 here. Firstly, you see the events that I see here, they do not give me any specific reason for this node to be in not ready status. I see node not ready, and here I see node worker 1 status is now node not ready. It is not giving me any other details. So if I scroll up, there is one thing that I want you to concentrate on, and that thing is taints. You see, there are 2 taints applied onto my worker node. So what happens is, firstly, whenever the status of the node is not ready or unreachable, the pods that are already running on this node will be evicted after 5 minutes. Now why 5 minutes? Because there is a duration of toleration seconds, which is 5 minutes by default. That is the reason the two pods that are running onto my node will be evicted after 5 minutes elapses post node not ready status. Now what I want to do is I want to take you to the Kubernetes documentation, and here I am. Here is taints and tolerations, and I will search for tolerations seconds. I think that's it is called toleration seconds. Yeah, toleration seconds it is. And if I come here further down, yeah, here it is. Kubernetes automatically adds a toleration when the node is not ready and unreachable with toleration seconds is equal to 300 seconds, which is 5 minutes. And if this stage happens, node lifecycle controller will automatically evict these pods, and then scheduler will have to reschedule them. In our scenario, if I clear my screen here, if I run kubectl get pods, then you see the pods have been terminated because 5 minutes have already elapsed, and I only have one worker in this cluster, which is why the pods are in pending state, because there is no other node where these pods can be scheduled, and my control plane node has a taint which prohibits these pods to run onto it. Hence we must fix the problem why this worker is in not ready status. So let's go to terminal 2. In this terminal I have SSH'd into my worker node. So what I will do here is, firstly, we know that kubectl describe didn't give us anything, and here the first thing in worker node that you can do is you can check for the status of kubelet service. I will run sudo systemctl status kubelet, and this will show me that the kubelet service is not running. It is enabled, which ensures that whenever there is a server reboot, the service starts automatically. But here I do not see active or running status, which implies the service is not in running state. So I will hit Q, and then I will run sudo systemctl start kubelet. Now this will start the kubelet for me, which is what we want right now. So let's again check the status of kubelet, and now the status is active and running. Let's go to the control plane node again. I will run kubectl get pods, and you see the pods that were in pending state are now in running state because worker 1 is now available. So if I run kubectl get nodes, I see the worker 1 is in ready status. Now this was a simple scenario but an effective one. The first sign of troubleshooting is to start with kubectl describe commands, then you move on to systemctl commands to check whether kubelet is running or not. Then let's move to the second scenario. I will run kubectl get nodes -w, and we see worker 1 is in not ready state now. So let's see what is wrong with it. Firstly, I will run kubectl describe nodes worker 1, and let's see if this gives me something. This is just saying worker 1 status is now node not ready, and it is the node controller that is giving me this error. Now let's see how we can troubleshoot it. Similar to like we did before, first let's run our favorite command in this scenario, sudo systemctl status kubelet, and this clearly says that kubelet is not running. We do not see anything else. It just says there has been a failure, that is status 1. Now let's see how do we troubleshoot it. If you have seen my previous lecture, and if I scroll to the right here, you can further see there is status 1 failure, code is exited. Now if you have seen my Kubernetes logging and monitoring session where we discussed about Kubernetes observability, we saw how do we check the logs for anything that is running as a service. For example, kubelet, we can use journal CTL, which can be helpful when you want to check the logs for anything that is running as service. So I'll hit Q here, and then I will clear my screen first, then I will write journal CTL. Here I will write -u. The unit for which I want to check the logs for is kubelet. In systemctl world, what you do is every service is defined using something called a unit file. Hence, all these services, be it kubelet, sshd, or any other services that are part of your operating system, these are called units. So I want to check the logs for -u unit kubelet, and I will press enter. Now this will give me everything, and if you see, the output will want me to switch to the right. I'll have to scroll to the right if I have to read everything. I don't like that, so I will hit quit Q. I will press the up arrow again, and here I will write no pager. By writing this, I can see everything at single place. It will just wrap the text for me. I'll press enter, and these are all the logs that are available for my kubelet. There are a lot of logs. Now here what I see is E stands for error, I stands for information, and there would be a W somewhere, and W stands for warning. I am specifically looking for errors here, which I see at the very last. E0827, it says command failed, error, failed to run kubelet, running with swap on is not supported. Please disable swap or set this parameter. Now firstly, we know what the problem is. This system has swap enabled, which Kubernetes is not liking. Now what is swap to begin with? When I talk about operating system, all of your applications, they prefer to run in memory. They prefer to take some space in your memory, that is your RAM. Now if your memory is full, then what can happen is these things can also leverage your hard disk and or your SSD disks. So what swap will essentially do is, whenever your memory is full, it will allow applications to use some part of your SSD to offload their workloads. Now what happens when you use swap is, firstly, your system becomes a little slow because your SSDs are not as fast as your memory. RAM will always be faster than your SSDs or your hard disks. Hence, when I talk about this Kubernetes setup, it is recommended that you do not switch on swap, because when you switch on swap, you do not get the real memory utilization of the server. And we are here creating control groups. We are also doing requests and limits which depend on actual utilization. So if you have swap enabled, it collides with those things. Hence it is recommended you switch off the swap. And when we were creating our cluster in day 54, I believe, we switched off the swap, and this is the reason we did that, so that there is some level of transparency between your kubelet and the operating system. Only then the decisions can be taken in a transparent way. So now to fix this problem, what we'll have to do is we'll have to disable swap. And why do we know swap was the problem? Because we know we must use journal CTL for anything that is running as service, and the logs will point us to the right direction. And here the logs suggested us that there is some problem with the swap. So now let's disable the swap, but before we do so, let's run swap on --show. So this will show me that there is a swap location /swap file which is of 1 GB. Then what I can do is I can also write free -h. This command will tell me my memory statistics, and here you can also see swap is also mentioned. So here it says there is 1 GB of swap, and here you see this is the total GB byte of memory available with this virtual machine or EC2 instance, because I am using a virtual machine spun in AWS. So we know that swap is enabled. How do we disable swap? So what I will do is I will quickly write sudo swap off, and then here is the swap I want to disable, and this should be only swap file. I'll remove this extra p, I'll press enter, and this will disable the swap. But I also want to delete this file, so I will write sudo rm-force, and I want to delete this swap file permanently. I'll press enter, and this will remove this swap file. Now if I run swap on --show, this will not return anything because we have essentially removed the swap. And if I go back to my control plane node, and if I run kubectl get nodes -w, you see as soon as I did that, the worker one is in ready state. But I always go a step ahead and also restart the kubelet service. So I will do sudo systemctl restart kubelet, and this will ensure that my job is successfully done. And here I see my kubelet is in ready status. Now let's move to scenario 3. I will now run kubectl get nodes -w again, and my node is in ready status right now. Let's give it some more time. My worker one is now in not ready status, and I must fix it. So let's do one thing. Let's repeat the same exercise again. I will run sudo systemctl status kubelet, and it shows me that the service is not running. And here again, I can also run kubectl describe nodes worker one, and this does not give me anything like before. It just says that node controller has a message, and this time as well it says node controller has a message, and that message is worker one status is now node not ready. So let's go back to our worker one again. I will hit Q, and this time as well I want to check the logs. I will run sudo journalctl -u kubelet to check the log for kubelet. I'll press enter, and I will press shift G to go to the very last of this line. I see some errors here, but here again I will have to scroll to the right to read all of these. I do not want to do that, so I'll press Q, and here I will write no pager. Now this command can take a lot of time if you are not supplying any additional flags. Let's see what the error is. Error says command failed, error failed to run kubelet, unable to load bootstrap kubeconfig. So I know there is some problem with my kubeconfig file. Let's see if there is something else as well. Now here something different is also there. Unable to read existing bootstrap client config from this location, invalid configuration, unable to read client certificate var lib kubelet pki, kubelet client current wrong.pem for default authentication due to this. This is clearly saying that there is something wrong with the file that holds the public key, that is the certificate. So let's see what is happening here. So what I will firstly do is I will cd into this location, and then I will run ls. Now this location tells me that the correct name of the file is this kubelet client current.pem, but what is configured? If I look at this here, it is saying that you have an invalid configuration in this file. So what is that invalid configuration? Let's check it. So I have copied this. We know that the correct one is this because the error logs pointed us directly to the problem. So I will write here sudo, and then I will write vim and I will paste that path here and I will press enter. Here the client certificate is wrongly mentioned. If you have watched my TLS lectures, you clearly understand that this is the certificate which kubelet will present when kubelet is acting as a client. And when kubelet is acting as a client, when it wants to read what all pods are there to be created, when it is verifying that from the API server. And when will API server be the client? API server will be the client with respect to kubelet when you as an administrator are running kubectl exec or kubectl logs command, because when you run those commands, API server in turn communicates with the kubelet to give you that information. So for now, I will quickly remove this wrong from here. I will hit escape shift ZZ to save this file. And once I have done it, I will write sudo systemctl restart kubelet and press enter. This will restart the kubelet and I will go back to my home directory here, and then I will go back to my control plane node. I will run kubectl get nodes -w and my worker 1 is in ready state again. So understand that we have done 3 scenarios and you would not be able to troubleshoot these 3 scenarios if your foundations are not clear. So with that understanding, let's move to our 4th scenario. And in the 4th scenario, we will be dealing with CNI troubleshooting. Now let's run kubectl get nodes -w again. And I see my worker 1 is again in not ready status. Let's first see if something is given here. Kubectl describe nodes worker 1. Again, if I see the recent events, it is not giving me anything substantial. It is just saying some things are off. Let's see what the problem is. I will go to worker 1 and here I will run sudo systemctl status kubelet. Why is this kubelet active and running? We are seeing not ready status. So let's further see what's going on. And I want you to notice a few things. Here it is saying pod workers error syncing pods, error network plugin not ready. Now 2 are the pods that are workload pods and rest are my daemon set. So daemon set pods and also my workload pods are not working properly because CNI plugin, which is Calico in our scenario, is not initialized properly. And to check this further, what we can also do is I will write sudo journal ctl -u kubelet. This will give me all the logs and I will write no pager here. And here you can see worker 1 kubelet. This is an error, pod workers error syncing pod, skipping this, the same thing that we saw there. Now I want you to know that whenever a CNI is installed, the configuration file for that CNI is placed in cd. I will go into that location etc CNI, and then there is a directory called net.d. But net.d does not exist here. So let's press enter here and I will hit ls. And if I do ls, I see there is net.d.back, but there is no net.d. And our configuration is expecting the configuration of the CNI file to be placed in net.d, not net.d.back. So right now, if I go in this directory, you see these are the, let me do one thing, I will do sudo ls net.d, and if I do that, I see there are 2 configuration files that are placed here, and these are required for our CNI to work properly, but they are in the wrong directory. So let's do one thing. Let's rename this directory to what the CNI configuration file is expected in. So what I will do is I will write move netd and I will rename this to net.d, and that is what is expected. I will press enter and I'll have to add a sudo here, and then it is done. So if I do ls, this is done. Now what I want to do is I want to write sudo systemctl restart kubelet. I'll press enter, and now let's check the status. The status was previously also running, but there were few errors. So let's see if those errors are gone. I will do this, and it is saying operation executed this. Let's go to our control plane node and see what is the status of the node. And the node's status is ready. So the crux is you should know in which location the configuration file for your CNI is placed, so that if they mess around with that, you can fix it. With that said, let's move to scenario 5, which is troubleshooting Kubernetes services. Now the problem statement that is given to us is, if I run kubectl get pods, I see there are 2 pods. If I run kubectl get svc, I also see there is a web-svc, and this service is fronting my deployment, which is named web. That is clear from these outputs. Now the problem statement is I am not able to access this service. Let's troubleshoot that problem. So what I will do is I will run kubectl run test pod. I will call this test pod. I will write -it, so I want an integrated terminal, and I will also add -rm so that this pod is deleted once I exit this pod. And then here I will write -bash because I want a bash shell. I should have also written -image. What image I want to use is nginx for this pod. I will press enter. What I will also do is I will also paste something here which will make my prompt colorful so that you can see properly. So I am in root @test pod. Ideally what should happen is if I write curl web -svc, I should see some output, and the output is not coming here. We have been asked to troubleshoot this problem and fix it. So I will exit from here. I know it is not accessible. I need to fix it now. First command that I will run is kubectl describe svc. The name of the service is web-svc. I'll press enter, and this clearly shows me that there are no endpoints. And I want you to know that the labels for which my service is looking for is app is equal to weeb. And let's see kubectl get pods -show labels. The label that my pods have is app is equal to web. I want you to clearly understand that services do not really care about what deployment is, what replica set is, what daemon set is. They just care about the labels, and based on those labels they will select your pods. Here my selector is app is equal to weeb, so this service will only load distribute to pods that have app is equal to weeb label, but my pods have app is equal to web label. Hence when we tried to curl web-svc, it did not work for us. Hence we must fix this, and to fix this I will write kubectl edit svc, and the name of the service is web-svc. I'll press enter, and I will go into insert mode by pressing I will come down. In the place of selector app is equal to weeb, I will just write app is equal to web. I will hit escape shift zz. This will save this file, and if I now run that command again, kubectl describe svc web svc, I see the endpoints are now filled, and these are the IP addresses of these 2 pods. Now let's do that testing again. I will again run a testing pod. I'll run this, and then I have copied that command, so I'll click on that. I'll paste it here. I'll press enter. I have a colored prompt now. I will write curl web-svc. I'll press enter. Tada, this works. So we have fixed the problem with a Kubernetes service, a ClusterIP service. Now let's exit this. This will delete this pod. I will clear my screen. Everything is hunky and dory. Now, before I let you go from here, whenever you are facing a problem like this, it makes sense to check whether kubeproxy is working properly or not, because we know that kubeproxy is the one that actually does the load distribution to different pods. So always kubectl get pods -n kube system. This will tell you what is the status of kubeproxy, and you see there are kubeproxy pods which are running. If you add -o wide here, you will see that both worker 1 and your control plane node has kubeproxy running. So it is worth checking that kubeproxy is indeed running whenever you are faced with a Kubernetes services troubleshooting scenario. And if there is some error with the pod status, you check the logs and fix that problem. Now, with that understanding, let's move to the next scenario. And next scenario is CoreDNS troubleshooting. So I will clear my screen here. We again have the same cluster. If I run kubectl get pods, I see here are my 2 pods. If I write kubectl get svc, I have my web service existing as before. Now again, it has been reported that web svc is inaccessible. So we will do the same thing again. I will run kubectl run -it -rm. The name of the pod is this time, let's say, my pod, and what I want to use is image nginx, and then I want bash, which is born again shell. I will press enter, and this will give me a prompt to my nginx pod. Here I will again run that so that I get colorful prompt, and I will paste this here. And if I run curl web -svc, I see I am not able to resolve this service. Firstly, if you see this problem in this screen, it is always worth to see how is your DNS configured. So if I do cat etc resolve.conf, you see that there is a name server configured whose IP is 10.96.0.10. I want you to clearly note that this is the IP that fronts your DNS pods. If this IP is not in line with what you see in the console, then there is something wrong. For example, we know that this is inaccessible right now. What I will do is I will exit this, and then I will run kubectl get svc -n kube system. And when I run this, what I see is the IP of kubeDNS cluster IP service is 10.96.0.10, which is rightly configured here. Now, these things look fine to me, and it says could not resolve host. And if you want, you can also run kubectl describe svc, and the name of our service was web-svc, and this shows endpoints are these. Selector is app is equal to web. If I run kubectl get pods --show labels, then what I see is labels are also fine. It is app is equal to web, app is equal to web, and as long as endpoints are being listed here, we know that the service is able to detect these pods. And I can also add -o wide to cross check that these are indeed the IP addresses of these 2 pods, which is correct in this scenario. The next thing I am concerned about is what is the status of my CoreDNS pod. So what I will run is I will run kubectl get pods -n kube system, and this shows me there is no CoreDNS pod here. So in this step, when I saw that kubeDNS service is working fine, what I should have done is I should have done kubectl describe svc -n kube system and kubeDNS is the service I want to describe. I should have pressed enter and this would have showed me there are no endpoints. And why I am saying I should have run this right after this, because there is a systematic approach to troubleshooting. First, you cross-checked the IP that you have configured is correct. Then you saw the kubeDNS service is this, but we should have also checked whether there are endpoints associated with this service. And when I did this, I saw there are no endpoints associated with this service. So now I know, because I have watched the DNS lecture in Kubernetes, I know that CoreDNS runs as a deployment. So if I run kubectl get deploy -n kube system, this will show me that there is a CoreDNS deployment, but that deployment does not have any pods. So what I will now do is, my dear friends, I will run kubectl scale -n kube system deployment, and the name of the deployment is CoreDNS, and I want to scale this deployment to how many replicas? I want 2 replicas for this. I'll press enter, and if I now run kubectl get pods -n kube system, I will see that there are CoreDNS pods created here 9 seconds ago. Now let's do the same thing again. I will run kubectl run my pod -it -rm, and then I will write image I want to use is nginx. I am deliberately not keeping a pod aside that is ready for troubleshooting. I am using this command again and again to ensure that you know that you will have to create testing pods on the fly to troubleshoot problems. Otherwise, what I typically do is, whenever I'm troubleshooting a problem, I keep a testing pod aside which has all the utilities already there. I will run kubectl get pods, then I will add --bash here, and then what I will now do is I will write curl web -svc, and this is working now. So the problem was there were no CoreDNS pods that could have resolved this name for us. And if I write ns lookup web svc, this will, I do not have ns lookup in this nginx image, hence this is saying command not found. What I will do is I will take you to the DNS lecture. So if I click on prerequisite, then here I have the DNS lecture. I will go to the repository, and here is the image that I want you to concentrate on. This is the image that you can use for troubleshooting. So netshoot is the image by Nikolaka. So I'll copy this and I will go here, I will exit this pod, and I will paste this here. I want to demonstrate with this image because this is a very good image for troubleshooting things, and you can also use this in your production scenarios to troubleshoot any network issues, because this has most of the tools already there. So I can write curl web svc and this will show it is working. I can also write ns lookup web svc. I have to spell lookup right, and I'll press enter, and this is saying that the IP of that service is this, and the DNS resolver for our request was this, and this is the IP of our kubeDNS service. That is the last scenario that I wanted to cover. I think you have got a good understanding of how troubleshooting works for data plane components, and if you go check out the GitHub repository, there are more scenarios there. Whenever you run commands like kubectl delete pods and the name of the pod, or there is a scale-in operation, or because of a taint which has an effect of no execute, and the pod running on that node does not have a toleration for that, then that pod will be removed, or for XYZ reasons for which a pod is terminated from the Kubernetes cluster. This process is adhered. So what happens is, as soon as you run kubectl delete pods my pod, then a sig term signal is sent to all the containers part of that pod. If these containers do not shut down within that stipulated time of 30 seconds, which is the default timer, then a sig kill signal is sent. Now what happens is all the major programming languages, they have something called an event handler. That event handler will handle these signals. Some call it event handler, or you can also call it signal handler. That signal handler knows how to handle these signals. So as soon as this signal is received, the containers will shut down. And once they are gracefully shut down, then the pod is terminated. Now at times what happens is, if you modify the handler and it is not able to handle this sig term signal, then the application fails to gracefully shut down, or the containers fail to gracefully shut down. If that is the case, then the containers are force terminated using the sig kill signals. And even if the handler is working fine, but the handler is not able to shut down the containers within this 30 seconds default grace period, in that case as well, a sig kill signal is sent. So in summary, the default period is 30 seconds. The containers are given 30 seconds to gracefully shut down. If they don't, then a sig kill is sent. Now this period is configurable. For example, if you see this snip, what I have done is, I know my application takes around 35 seconds to shut down. That is why I have increased the termination grace period seconds value to 40 seconds. In this particular example, both these containers will have 40 seconds to gracefully shut down. If they don't, they will be forcefully terminated with a sig kill signal. Now let's see what these commands do. When you run kubectl delete pod mypod, this process is followed, which I just shared. If you add a flag --force is equal to true, then the pod object is deleted immediately. However, the kubelet still continues to monitor those containers. So what I mean by that is, when you run kubectl get pods, the pod object will not be seen if force is equal to true. So as soon as you apply this and you run kubectl get pods, you won't see my pod there, because we have deleted the pod object, and kubectl client uses API server to interact with your Kubernetes cluster. And since API server does not have any information about the pod object, you don't see the pod object. What happens if you additionally add one more flag in this command, and that flag is grace period is equal to 0? You are saying here, I don't care if the application shuts down or not. I want to send the sig kill signal immediately. That is what this command will do. So you can use this for force deletion. This you can use for force deletion when you don't want to send sig term signal at all. In this, a sig kill signal is sent and containers gracefully terminates. It's just that you don't see the pod object. Now let's move to the next section. Next section is restart policies. Restart policies govern when your pods are restarted. This is a pod level specification. Hence, the restart policy, once defined, applies to all the containers in a pod. The first policy I want to discuss is always. The use case for this is commonly used in deployments, and you can also say deployments, stateful sets, and daemon sets. If you don't know these things, do not worry, we have not discussed these yet, but we'll discuss them later. But for now, understand that the restart policy always is the default for these scenarios, and also when you manually create a pod. The behavior is the container is restarted regardless of its exit code. What do we mean by that? So there could be two scenarios. One scenario is when I want my application to continuously run all the time. What are examples of these applications? Nginx server. Nginx is my web server, which is my front end. I do not want Nginx to ever shut down. I want it to continuously run. If something fails, I want that container, that pod to immediately restart so that my application is up and running. And whereas if let's say I have an application that pings an IP address and I just want to see whether that IP address is pingable or not, that pod I want to just ping 4.4.4 and then its job is done. I don't want it to run anymore. Hence, I would not want that pod to restart once it has finished its job. But before you understand these things, I should mention one more thing. Containers are supposed to go once they have finished their job. We discussed in the Docker section that containers are ephemeral. Once they have done their job, they go. The job of a web server is to continuously serve traffic, so that web server is supposed to run all the time. However, if one of the container is supposed to just ping an IP address and go back to sleep, then that container's job is done. That container's job is completed. So I don't want to restart that container. Hence, I am saying always behavior, the container is restarted regardless of its exit code. Exit code 0 implies a success. Even if the container is successful, for example, ping 4.4, if that is successful, do I still want to restart that container? I don't want. Exit code is 0. I don't want the container to restart. But Nginx is a web server. I want that to continuously run. Hence, the behavior when the restart policy is set to always is the container is restarted regardless of its exit code. And this is the default for these things, but you may want to change it based on your application demands. For example, if you are running a one-time job using deployments, which you should not, then in that scenario, you might want to change the restart policy to OnFailure or never, which we are going to discuss in a little while. Example, in a typical web application where continuous availability is paramount, using always ensures the pod is perpetually running. That's what we discussed. Now, don't limit your thinking to web servers only. We have discussed backend in our previous examples, and then we have discussed about microservices. There is a wishlist microservice, there is an orders microservice, there is payments microservice. I don't want these microservices to be down. So the deployment that is taking care of these microservices, I want that deployment, I want those pods to continuously run. Hence, for all these, I want the restart policy to be always, so that even if a pod is down, the kubelet quickly restarts it. Let's go back now. So first is always. Then there is OnFailure. OnFailure implies that if the job fails, only then restart it. Now, how does the kubelet know that there is a failure? So we discussed exit codes a little while. Exit code 0 implies success, anything else applies failure. So for example, if I am running a job that pings just an IP address 4.4.4 for example, then I would want the restart policy for that pod to be OnFailure, so that if it pings 4.4, I am fine, don't restart it. But if it is unable to ping 4.4.4, then you restart that pod for me until it can successfully ping 4.4.4. As simple as that. Use case often used in jobs or cron jobs or batch processing. That's understood. One-off tasks. You want to copy one file from one place to another, and once that copy is done, I don't want that pod to be running. I don't want that pod to consume my resources, so do not restart it. Just give it the complete status and let it stay, and then I will have my some sort of cron job or some sort of automation to delete the completed pods. Behavior, the container is restarted only if it exits with a non-zero status. That is something that we already discussed. Example is, think of data processing job. If it fails due to an error, Kubernetes will try to restart it. However, if the job completes successfully with exit code 0, it won't be restarted. And why is this behavior? Because kubelet only restarts the pods that have defined on failure if that pod has failed. And we know the pod has failed if it has an exit code of non-zero. As simple as that. Now let's discuss never. Never is self-explanatory. You never restart the pod. Even if the job fails, you do not want to restart that pod. Now, why would you use that? Let's say if a job is continuously failing, you want to troubleshoot why that job is failing. So what I'll do is I'll say never restart it, and then I'll check the logs and I'll fix that problem. And used when restarting is undesirable. There could be certain corner cases when you do not want your pods to restart. In that case, you would use never. Behavior, the container is not restarted even if it exits with a failure code. Example, this policy is useful for one-off diagnostic pods where you want to see the results of a container execution without further restarts. That is understood. Never is not the default for any object. On failure is default for jobs and cron jobs. We have not seen these objects yet. We'll see them later in this course. Always is the default for deployments, stateful sets, daemon sets, and even when you manually create pods, like we have been using CLI to create pods, the restart policy for those pods is set to always. Then I want to discuss this as well with you. Now, if you see this image, this is the spec section for the pod, and just beneath that we have defined the restart policy, and this is always. Here the kind is job. You see, I want this pod to only restart when there is a failure. And then there is a diagnostic pod here whose restart policy is set to never, because I do not want it to ever restart. I hope these things are clear. As we progress with this lecture, we'll see examples of these here and there. But for now, let's move to the next section, which is image pull policy. The first thing I want you to note, image pull policy is a container level thing. So you can have a different image policy for every container in your pod. Would you want to do that? I don't think so. But if you have a use case for that, be my guest. So the first image policy is always. Use case, use always in development environment. So image pull policy, let's first understand the definition. It's saying when should the container runtime pull the image from the registry? Should it pull the image even if the image is cached? Or should it never pull the image from registry? So all these behaviors are defined by image pull policy and the value that you assign to it. So the first value that you can assign is always. Use case, use always in development environment. In development environment, you would often use the latest tag. And if you don't supply a tag, latest is automatically added. But I want you to understand one thing. Today, the latest is pulling, let's say, this image, my first image v1. Okay, and tomorrow this could fetch 1.0.1, and day after tomorrow this could be 1.0.2, and then this number will go on increasing. So in development environment, you do not care what the version of the image is. I just want the latest image to be available to me. In that case, you would use always. But in production environments, you want to be definite. You want to say with conviction that I want this version only. Do not give me any other version of the image. I want to also explain this. I'm saying version 1.0.0. You will often see versioning done in this way. So here the one that you see is the major version. Then you see a minor version, and then there is a patch release. So you will often see application developers name their images like this: major version, then you have a minor version, and then you have a patch release. Patch release is usually to fix some bugs in the release. So this is the format that you will often see. Now, behavior is image is pulled every time the container starts, ensuring the most recent image is used. This is understood. Then let's see if not present. Use case: use if not present in production environments to avoid unnecessary image pulls. When you are dealing with a production grade environment, you have different nodes. You do not want to pull the image every time, because firstly it takes bandwidth, and then the node's utilization also increases while downloading the image. Hence, in production environments, you do not want to use if not present. And like I mentioned before, you definitely, most definitely, do not want to use always in production, because always will be pulling a different version all the time, because your developers are continuously improving. Hence, you do not want the latest version in production. You want to specify the version that you wish to use in production. Like we have specified here, my app version 1.2.3. Behavior: use the image in node's cache or pull it from the registry if it isn't present. A key point to understand. There is one important thing I want to highlight here. Let's say you have a team of 2 developers. There is Varun and then there is Kavita. Varun pushed an image with the version tag v1.0.1. Then there is Kavita. What Kavita did was, Kavita also created an image, and what Kavita did, Kavita used the same image tag. There's nothing stopping her. Registry has an image with tag 1.0.1 which was pushed by Varun, and then it also has the same tag by Kavita. Now imagine if you have 2 nodes. This is one node, node 1, this is worker node 1, and then you have a node 2, and here is node 2. When a pod in node 1 was fetching the image, that pod received 1.0.1 which was pushed by Varun, and when node 2 there was a pod that was supposed to use the same image, it pulled the image pushed by Kavita. This is a problem. Node 1 has a different image, maybe because we don't know what changes Varun did, and we most definitely do not know what changes Kavita did. So both these images have the same tag, but they are using different version of the application essentially. This runs a different code and this one is running a different code, because my developers pushed the image using the same tag. Now, how do we prohibit this situation? See, whenever you have build tools or pushing certain images to your registry, there should always be a check that the version that exists, the tag that exists in the registry, another developer should not push the image with the same tag. Keep this in mind. I have mentioned this so that you know that if not present could be tricky if you are not adhering to a process like this. You must ensure that developers are not pushing the images with the same tags, and you cannot ask them to do so, that do not do this, do not do this. You should have automation in place that prohibits this behavior. So I want you to keep this in mind. Then the last one is never. Never says never pull an image. But Varun, if we never pull the image, then how will we run the containers? How will we run the pods? You remember when in the last lecture my connection to the internet was lost and I was unable to pull the images because we were pulling images from a public registry, and pull the image from public registries we need internet access, and since my connection to the internet was down, I was not able to pull any images. And why was it pulling images all the time to begin with? Because my pull policy was always. For now, understand that in my demo the image was pulled always, because if you do not supply a tag or you are using the latest tag, then the default image pull policy is always, which is why it was trying to always pull the image even if an image was cached with the same name. But since with latest and when you supply no tags, it will always pull the image by default. hence it was trying to pull the image all the time. So let's get back to this never again. Use never in air-gapped environments or scenarios where nodes are preloaded with container images and external image pulls are not allowed. So what are air-gapped environments? So air-gapped environments are tightly governed environments where your servers are isolated from the external network. They do not have internet access. If you want the pods to have never as the image pull policy, then you will have to load your nodes with the appropriate images beforehand. Behavior: if the image is not present locally on the node, the pod will fail to start, and that is obvious. So now let's discuss this. The default value for image pull policy depends on how you define the image in your pod specification. So in the pod specification here within the container block, because we said that this is a container level thing, you apply it at per container level. So always is the default for images with the latest or no tag. Example, nginx:\latest. If not present, any image that you define with this tag, with the version tag, then the default will be if not present. If you remember, in day 10 we discussed deployments, and in that we practiced rolling back and rolling updates. There we used images with version tag. So it is imperative in production environments you use images that have version tags. I hope this is clear to you. Let's now move to the next section, which is pod lifecycle phases. Now before I start explaining this, I want you all to have watched day 7, because day 7 is where I explained the deployment creation workflow. So if you have not seen that lecture, do see it to have an understanding of how the control plane and data plane component work together to ensure your workloads run properly, and what happens behind the scenes, what role each component play when you create a deployment. So we have discussed this thoroughly in day 7. Just go and watch it. I'll give a brief of what happens when you create a pod. Let's say administrator sent a request, create a pod for me. The API server, as soon as it receives this request, it will send a confirmation to the administrator that the pod is created. But Varun, right now nothing has happened. How can it say that? But if I go here, go to the terminal, and if I run kubectl, run my pod and use the image, I'll say something gibberish, okay? Amazing me. I'll just mention this and I'll hit enter. It said the pod created, even though there could be error with the pod, and the error is error image pull, which says that I'm not able to pull this image because I don't find any image named amazing me in Docker Hub, because Docker Hub is the default registry for Kubernetes to look for images. And here it says error image pull, but you saw the pod is created. So as soon as you run this command, the API server writes to etcd that there is a pod object created, and then a confirmation is sent to the administrator. And then scheduler sees via the API server that there is a pod that does not have a node assigned yet. Then scheduler will look which node can this pod be assigned to. If I go to day 15, scheduler will make these considerations. It will check the resource availability in the nodes. It will check for taints and tolerations, affinity and anti-affinity rules before assigning a node to a pod. Now kubelet will assign a node. It will update the node name property, and the API server will update the node name property in the etcd database. Then kubelet receives this information via the API server that these are the container specification for which you have to create a container. Then kubelet invokes the container runtime. Then container runtime will pull the image. It will set up the networking using the CNI. It will create control groups, and it will eventually mount the volumes, see the environment variables, and then it will eventually create the container. And you have a pod with a container running after that. So this workflow we understand. Now let's see how this maps to the states that you see here. Now first is the pending state. So this says that the pod has been accepted by the Kubernetes cluster, but containers are not yet running. Reasons include image pull delays, unscheduled pods, and so on. So the first thing is scheduling. If your pod is in pending state, that implies that your scheduler has not yet scheduled the pod, or there are image pulling problems. Pending state implies this. There is also a subphase here, container creating, and we will see this subphase when we do the practicals. Then there is a running phase. Oh, I think I did not say what we are discussing. We are discussing pod lifecycle phases. So if I go to the terminal and I run kubectl get pods, there are different status messages that you will see. We are discussing the lifecycle phases, but you would be saying that I don't see error image pulls here. So we have a separate section where we will discuss common errors, but right now we are just discussing the main phases that you would often see. Those are essentially the errors. These, what you see here, depict the state of the pod as a whole. Second is running. So running implies pod has been scheduled to a node and all containers are either running or starting. An important distinction, because if there are two containers in a pod and one container is running fine but another container is facing some problem, then the status will never be running, because the status that you see here will represent the worst container. So if you have 5 containers, 4 are running fine and the 5th container has error image pull error, then this will say out of 4 only 3 are ready and the status will be error image pull, because this status depicts the status of the worst container inside that pod. Overall pod status in kubectl get pods reflects the worst container state. We have also mentioned this here. Then you have succeeded. All containers in the pod have terminated successfully. Successfully implies exit code 0 and the pod won't restart. Here is the catch. Kubernetes in the documentation calls it succeeded, but if you run kubectl get status, you will see completed here. So succeeded is a phase and completed is something that you will see visually in the status section. So we'll see this in a while. The pod has completed its life cycle and all containers within the pod have terminated successfully, exit code 0. Now I want you to go back to jobs here. In the job, we said that once the job completes, it should not be restarted. So when the pod that is running a job completes, you will see the status as succeeded for it, because it has exited with exit code 0. And you will only see succeeded if the policy, if the restart policy is set to on failure or never, because if you have set the restart policy to always, then as soon as the pod has completed its job, it will be restarted. I don't want that behavior for certain pods. But understand, succeeded will only be there when the container has performed its job and is not getting restarted. Then only you will see the completed status in the CLI, and in the when you run a kubectl describe, you will see succeeded there. Then there is failed. All containers have terminated, but at least one exited with failure, that is non-zero exit code, and is not set for automatic restarts. The job has failed. Okay, the job has failed, but we are not restarting. In that case, the pod will be in the failed state. Now the pod can have 5 containers, but even if one container is in failed state, this failed status will be depicted. The pod life cycle has ended, but one or more containers have failed, exited with non-zero status code. And here I should also add, and the policy is to not restart, because if the pods are continuously getting restarted, then they will not be in the failed status. They will be in crash loop back off, and we'll see what that error implies. So it is imperative that you understand both restart policies and life cycle phases, and life cycle phases depend a lot on what is your restart policy, because you won't see succeeded and failed if your pods are continuously getting restarted. Note these points. Then we have unknown. Unknown is usually because of infrastructure problems. Maybe the underlying node on which the pod runs is facing some issue. That is when you will see unknown errors. Now, Kubernetes cannot determine the pod state, often due to communication issues with the node where the pod is running, often because of infrastructure failures. I hope all these states are understood. Now let's go to the terminal and do a demo for this. I will go to shell and I'll write split vertically with current profile. This looks good. Now here I will run kubectl get pods -w. -w is -watch. What this will do is it will display the results whenever there are any status changes. So I'll hit enter. We know that this pod is in image pull back off. Previously it was in a different state. Previously this stated that it was error pull image, but now the status has changed to image pull back off. I want you to keep this in mind because I'll circle back to this point in a little while. If I now go here, I will run kubectl run ubuntu 1 and the image I want to use is of Ubuntu. Now before I hit enter, what is the Ubuntu pod supposed to do by default? And let's see that in a little while. Park that question. I pressed enter. It said pod creating, and here I see the pending state, the container creating state, and the completed state. And now it went to crash loop back off. I'll take you back here. What we discussed here. When you manually create a pod, what the policy is by default? The policy is always, even though the container has completed what it was supposed to do, kubelet restarted it. Why did this happen? This happened because of the restart policy. So see, the container again got completed, but kubelet will again restart it because by default the restart policy will restart the pods. Now I wanted to concentrate on the stages here. First it was in pending state like we discussed before, then it went to the container creating phase, and then it completed. Why did it complete before the running stage? We did not see the running stage. To answer that question, let's first do one thing. I will use docker pull ubuntu. I'll pull the ubuntu image. Oh, sorry, docker pull ubuntu, and it is now pulling the latest ubuntu image. So it has done so. Now I will run docker inspect ubuntu. This will inspect this image for me. And if I scroll up, the ubuntu image by default is just supposed to run bash, and once it has run bash, it has completed its job. And like we said before, when something has finished its job in containerization world, it just goes away. It completes. Hence you see the status completed. But Varun, it did run bin bash. Why did I not see the running state here? You did not see the running state here because this took a fraction of milliseconds to complete. Hence this could not display that running status. What I will now do is, you now know that the Ubuntu image by default is just supposed to run bash. Okay, we know that. Now I'll clear my screen. I will now run the same command again, but I'll add a few things. I'll name this to, let's first delete Ubuntu 1 so that we do not see these status messages on the left. I'll run docker, kubectl delete pods Ubuntu 1. I want to delete Ubuntu 1. Ubuntu 1 stands deleted. So now I will again go back to that command docker run Ubuntu 1. I'll add two things here. First I'll add restart is equal to never, and now we know what will never do. Once the container completes, it will stay in the completed state. And I will now add a command here. This, what I'm doing now is I am overwriting the default command which was bin bash. So I will write here sleep 5. Now sleep 5 will give this container 5 seconds. So ideally we should see the running status on the left, and I'll name this container Ubuntu 2 to avoid any confusion with the previous data. I'll press enter. It said created. And now you see Ubuntu 2 pending state, Ubuntu 2 container creating state, Ubuntu 2 running state, Ubuntu 2 completed. And you did not see any crash loop back off or anything else because we have asked this to never restart. Hence, this pod completed what it was supposed to do and is now resting. I hope this put things into perspective, and now you are able to clearly visualize what is happening behind the scenes. Now let's discuss these errors, because these errors are important for understanding the common pod errors. And crash loop backoff, error image pull, and there was one more that we discussed before, image pull backoff and error image pull. These are the common errors that you will see. Let's discuss these errors now. I'll go to my Chrome browser and let's discuss these errors. First is crash loop backoff. Containers repeatedly crashes and is restarted with exponential backoff. What is exponential backoff? So exponential backoff says restart. The first restart should be performed at 10 seconds, second restart at 20, third restart at 40, fourth restart at 80 seconds, and so on. And it will do this till the 5-minute timer, and after that it will restart that every 5 minutes. So this will continue to go on. And why would crash loop backoff state come? Because you have created a deployment, let's say, which has the restart policy of always, and then your containers are facing some problem. That problem could be related to environment variables, it could be related to probes, could be misconfiguration. There are plethora of reasons for that. You would also see OOM killed, container is killed, it is again restarting, but it is again using memory more than the specified limit. Then you will see these errors. Liveness probe failures, we'll be seeing probes in the next lecture. Application errors or bugs. So crash loop backoff is the most common error that you will see. And first discuss error image pull. Error image pull will come when you have specified the wrong image, or maybe you are trying to pull an image from a private registry whose authentication is not correct. So currently we have been using public images which are available in public registries. We are pulling Nginx, which is a public image, so we need not to supply any credentials for that. But when you are working in production environments, you will have to supply authentication to access the private registry where your images are held. In that scenario, you will have to provide authentication. If authentication is not provided correctly, then you will see error image pull. So what is the difference between error image pull and image pull backoff? Error image pull is the first stage, and similar to crash loop backoff, there is a backoff timer for the image pull as well. If it continuously fails to pull the image, your container, your pod will go in image pull backoff state, like we saw in this lecture. Error was first error image pull, and then it changed to image pull backoff. So first you will see this, and then it will eventually turn to this. And the cause for error image pull could also be registry network connectivity issue. We saw that in our previous lecture. When my internet connection was down, I was not able to pull the images. And then you will also see OOM killed, and we know why we see OOM killed. This is because your containers are using memory more than the limits that are defined for your containers. Then there is unknown, and this is again, like we said before, this is usually because of infrastructure failures related to nodes. All these errors, the important commands to troubleshoot is, first is kubectl events, and then you can check the logs of your pods using kubectl logs. Then kubectl describe is the one I have used the most. Let me see if I want to cover something else. Oh, that's all. That wraps up our Kubernetes troubleshooting masterclass. We walked the control plane, etcd, API server, controller manager, and the scheduler. We then dug into data plane, kubelet, kubeproxy, CNI, and CoreDNS, and resolved pod and application failures with clear, repeatable steps. Please practice each scenario in your own lab to solidify the concepts. If you have any suggestions for me, I would be grateful to hear them in the comments. If this session helped, a short note about what worked or what I should improve would be very helpful, and sharing it with a colleague would definitely mean a lot to me. If you would like to follow along, you are welcome to subscribe. I will be covering Jenkins, Argo CD, observability, and more practical sessions in the near future. Thank you very much.